Hello, grade 12s. How are you? Mr. Newlove is here again. Today, I want us to look at continuation of probability, which is series 2. If you've not watched the first one, try and watch it before you come to this one. Okay. If you've not subscribed, subscribe. Okay, let's get down to business. The question here, this is a past question. It says, an organization decided to distribute gift bag of sweets to grade R classes or grade R class at a certain school. There is a mystery gift in exactly 1/4 of the total number of bags. Each learner in the class may randomly select 2 gift bags of sweets, one after the other. The probability that a learner selects 2 bags of sweets with a mystery gift is 7/118. Calculate the number of bags of sweets with a mystery inside. Okay, this one is a past question. And remember, I told you probability is number of successes over total outcome. Good. So the first thing that we are going to do is this. We can use 2 ways of solving it using the tree diagram, which we learned in grade 11. There's another way which I'm going to show you now. Okay. The first one, we can let the mystery gift bag be equals to x. Mystery gift bag be equal to x, because if you check, the question says calculate the number of gifts of sweets with a mystery gift inside. So the bag that contained mystery gifts, let's call it x, because it was not given in the question. We don't know. That's what we are finding. Then it means the total number of bags is going to be 4x. Why? Okay, I'm going to show you. If you come here, there is a mystery gift of exactly 1/4 of the total number of bags. Are we together? So it means if the bag is 1, if the mystery gift is 1, the total number of bags is going to be 4. Because probability of mystery gift is 1/4, which is number of success, which is 1 for the mystery gift, then over the total, which is 4. Alright, so here, if the mystery gift is x, which we want to calculate, they want the total number of mystery gift. If it is x, it means the total number of bags is going to be what? 4x, 4 times x. Are we together? Okay. Then it means if you check this side, the probability that a learner select 2 bags of sweets with a mystery gift is this one. So it means there is 2 bags, or a learner selected gift from 2 bags, the first bag and the second bag. Alright, so for him to select a gift from the first bag is going to be x over 4/x. And the second bag, remember, 1 mystery gift has already been selected, so it's going to be -1. So it's going to be x minus 1 over, if you select 1 from the bag, which is a mystery gift, you have reduced it by 1, so it's also going to be -1. The total outcome is also going to be what? -1. So this should be equal to what? 7/118. Okay. Now this x is going to cancel. We are going to have 1 over 4, and we can transpose this. It's multiplied, so it's going to divide, so it's going to be the reciprocal. So the 4 will go up and the 1 will come down. And if you simplify this, let's simplify this one using our calculator. Okay, so here I'm going to have 7 over 1, 8 times 4 over 1. 4 over 1 is the same as 4, which is going to give us 14 over 59. And 14 over 59, what do? We cross multiply. So you cross multiply, so the 59 is going to multiply this, and the 14 is also going to multiply that one. Now if I cross multiply, I'm going to get this. So this 59 will multiply this, it will give us this. 59 will multiply 1, it will give us minus 49. So 59 times negative 1 will give us minus 59. Then 14 times 4 will give us 56. Let's check on our calculator. 14 times 4 gives us 56. Then 14 times negative 1 will give us what? Negative 4. Then we need to group the like terms. So I'm going to transpose this 56 to this side. It's going to be minus 56x is equals to minus 14. If I transpose this minus 59 to this side, it's going to be plus 59. Then 59 minus 56 will give us 3. So we have 3x minus 14 plus 59 will give us 45. Then we divide both sides by 3. If I divide both sides by 3, I'm going to get 15. So a bag with a mystery gift is going to be what? 15. Remember we said let x be the bag with a mystery gift. So we have solved the question. Okay, let's move on to the next one. But before that, there was this classwork I want you to do for me, similar to what we've done. Try and do it. So the same question, just that similar. I've changed the values. So you look at the example, you pause the video, copy this, and the continuation is this one. Good. So we have this one. Copy this. You pause the video, you copy, then you leave, you continue up to this side. So this is your classwork. I hope you are fine. Okay, so the next thing that we are going to do is we are going to look at this one, which says Valley and Bongani. That is where you are. Valley and Bongani, what have they done? Our learners are the same school. Some days they arrive late at school. The probability that neither Valley nor Bongani will arrive late on any day is 0.7. Calculate the probability that at least one of two learners will arrive late on a randomly selected day. At least. Anytime you hear at least, let me show you about at least before we continue with the work. Now, assuming I have the probability. Okay, assuming I have the probability that at least one boy will come to school late. Probability that at least one boy will come to school at late. What is it going to be? So probability that at least one boy, let me say one boy, I'm using this one to represent one boy. One boy will come to school at least is going to be 1 minus probability that that boy will not come to school late. So how do you represent that with a complement? It means probability that a boy will come, at least a boy will come to school late is going to be 1 minus probability that that boy will not come to school late. That is at least. Alright. The probability that a boy will not come to school late is going to be 1 minus probability that a boy will come to school late. That's one thing you need to know. The another thing you need to know is probability of an event occurring plus probability of an event not occurring is equals to 1. Let me give an example. Probability that I will go to school today plus probability that I will not go to school today is equals to 1. Probability that I will eat today plus probability that I will not eat today is equals to 1. So this condition we need to know. Alright. Okay, so we are going to use this idea, especially the first one here, to answer this question. They said calculate the probability that at least one of the two learners will arrive late on a randomly selected day. So we try to use this one. Let's see how we are going to answer that one. So we let the event Verily arrive late for school to be vain. So event that Verily will arrive late for school is vain, and the event that Bongani will arrive late for school to be B. Event that Verily will arrive late, let's call it vain. Event that Bongani will arrive late for school, let's call it B. Then it means the event that at least one of the boys, we can also write it this way, it can be Verily coming late or Bongani coming late, or both. Is that okay? So, or both of them coming late. It can be like that. So here, the event that Verily coming late or Bongani coming late, or we cannot use both of them because it says at least one of, at least means one or more, so both of them can also be included. All right, so the event that Verily coming late or Bongani coming late, or both of them coming late, is going to be 1 minus event that both of them don't come late. So here the information is given here. We have Verily and Bongani are learners at the same school. Some days they arrive late at school. The probability that neither Verily nor Bongani will arrive late on school is this one. So it means the probability that neither of them come late. In other words, probability that all of them, both Verily and Bongani, come early is 0.7. Are we together? Remember, we said probability of at least of events coming is 1 minus at least of events not coming. So probability of at least B should be equal to 1 minus not B. So here our not B is this one. Probability that at least all of them, one of them come late is 1 minus all of them not coming late. Okay, so this one is going to give us 0.7. And when you continue with the question, our answer for that one is 0.7 is this one. Then when you continue with this, the probability that Verly arrived late for school on a randomly selected day is 0.5. They've given us the probability. What is the probability that both of them arrive late for school on that day? While the probability that both of them arrive late for school on that day is 0.15. Calculate the probability that Bongani will arrive late for school on that day. Okay, so this also, this is our question. Let's look at how we answer it here. Now it means probability, we are calculating the probability that Bongani will arrive late for school on that day. Okay, we want Bongani B, but we know that probability that at least both of them will come to school. Another way of writing is probability that Verly will come to school, or means plus probability that Bongani will come to school late minus probability that both of them will come to school late. That's the meaning. So probability that Verly will come to school, or in other words, probability that at least one of the two boys, that is Verly and Bongani, will come to school late will be equal to probability that Verly will come to school late, or probability that Bongani will come to school late, or that is minus here, probability that both of them will come to school late. Two sets problem, man. Okay, now this information is giving probability that at least both of them will come to school late. We have calculated it to be 0.3. It was at the top here. Remember, we got this one, 0.3. Then probability that Verly will come to school late, it is given in the question, 0.25. It says probability that Verly arrive late for school is what? 0.25 is given. Probability that Bongani will come to school late, it was not given. That is what they want us to find. Will arrive for school on that day late. Then minus probability that both of them will come to school late. It's also given here. While the probability that both of them arrive for school on that day is 0.15. Now if I simplify this, 0.25 minus 0.15 is going to give me 0.1. Then you subtract. So we have 0.25 minus 0.15, which is going to give us 0.1. Then we transpose this one to this side. Is going to be 0.3 minus 0.1. So if I transpose, what am I going to have? 0.3 minus 0.1. And this one is going to give us 0.2. So Bongani will arrive, the probability that Bongani will arrive at school late is going to be 0.2. Then let's move on to the next question. The principal suspects that the late coming of the two learners are linked. the principal asks you to determine whether the event of Verley arriving late for school and Bongani arriving for school are statistically independent or not. What will be your response to him? Show or calculation. For them to arrive at school to be independent, there's independence rule. We also talked about it in the previous video. For Verley and Bongani to be independent, Verley and Bongani should be equal to probability of Verley times probability of Bongani coming to school late. Alright, so for them to be independent, let's see. We are going to multiply this and this. We want to find out whether they are independent or not. That's the question. Alright, independent or not, we want to find out. So we know probability of Verley come to school late is 0.25 and probability of Bongani coming to school late is 0.2. How? We're given here probability of Verley come to school late, it was given in the previous question, is 0.25. It was given here. Probability that Verley arrive late for school on a randomly selected day is 0.25. And the probability that Bongani will arrive late for school, we also calculated it to be 0.2. This one, Bongani arriving at school late, is going to be 0.2. So if I multiply this two, what am I going to get? I'm going to get 0.05. Is it the same as the one given in the early probability that, remember, probability that Verley will arrive late and Bongani will arrive late? It was given in the question to be 0.15, while the probability that both of them means n, this and that, both of them arrive late for school on that day is 0.15. It was given in the question that it is this one. So you see that when we calculated it, it was 0.05, and the same thing, the one that was given to us in the question is 0.15. It's not the same. Alright, so we can conclude that probability of Bongani, Verley coming to school late and Bongani coming to school late is not equal to probability of Verley coming to school and Bongani coming to school. Is that okay? So they are not independent. We can conclude that they are not independent. Okay, so you are going to do this classwork for me. Let me bring it up. This is going to be your classwork. So Agnes and Bongani are learners. You write that one, pause the video and write. Then probability that neither Agnes or Bongani will arrive late, you pause the video and write. Okay, then this one also, you pause the video and continue to write. You write in your book and you do it nicely for me. Okay, let's look at example 3. Our example 3, it says the success rate of Bafana soccer team depend on a number of factors. The players is one of the factors that influence the outcome of the match. The players, the fitness of the players should be the fitness of the players is one of the factors that influence the outcome of the game. If the player is fit, yeah, you may win. But if they are not fit, you may not win. It's easy to win when players are fit than when they are not fit. Okay. Now, the probability that all the players are fit for the next match is 70%. If all the players are fit to play the next match, the probability of winning the next match is 85%. If all the players are not fit to play the next match, the probability that the match is 55%. Based on fitness alone, calculate the probability that Fana soccer team will win the next match. We are only considering fitness. We know there are other factors that will cause players to win the match. If all the players come, it's also another factor, but we are only considering fitness. Alright. Okay, let's see how we'll solve this question. This one we can use the tree diagram. Remember the first one I told you can use the tree diagram, the first question. This one also we can use the tree diagram. We learned the tree diagram in grade 11. Yeah, you see that we are repeating it here again. Okay, now when we check the first information, we are using F for fit, a player to be fit, and not F means a player is not fit. Okay, so we are going to use the tree diagram to answer this. Now if you check the first one, the question says the probability that all the players are fit for the next match is 70%. So it means the probability that all the players are fit is what, 0.7. How did we get it? 70% is the same as what? 0.7. So 70% is the same as 70 divided by 100, which is 0.7. Alright, now it means if the player is fit is 0.7, then the player to be not fit is going to be 0.3. How did you get that one? It's going to be 1 minus 0.7, which is 0.3. Remember I said probability of an event occurring plus probability of an event not occurring is equals to 1. So if our event occurring is 0.7, probability of an event of not occurring is going to be 1 minus 0.7, because I'm going to transpose the event not occurring to be the other side, which is going to be minus. So it's going to be 1 minus 0.7, which is 0.3. Alright, then the question continued to say that, so this is our first tree diagram. Then the question continued to give us information that if all the players are fit to play the next match, all the players are fit, it means here if all the players are fit the next match, the probability of winning the next match, so this is the next match, is 0.5. So in the next match you may either win or lose. Are we together? So the first match the players are fit or not fit. So the players may be fit or may not be fit. If they are fit, they may lose or they may win or lose. If they are not fit, they may still win or lose. It depends. Alright, so if the players are fit, they may win or lose. And the question says, if all the players are fit to play the next match, the probability of winning the next match is 0.85. So if the players are fit, the probability of winning, so win is 0.85, which is 85%. So 85% is what? 0.85. How do you get it? 85 divided by 100, which is 0.85. Okay, so if the players are fit, what's the probability that they will lose the next match? How do you do it? It's 1 minus 0.85, 0.85, which is 0.15. It gives us this value. Alright, so if the players, now let's look at the next one. We are done with this. If the players are not fit, they may win or lose. And we're given information here that if there are players that are not fit to play the next match, the probability of the match is 55. So the probability of winning, So we put winning here. Probability of winning the match is 55.7. So if the players are not fit, the probability of winning the match is what? 0.55, which is 55. So 55 over 100 this time, you know, which is 0.55. Now this side. So the probability of not, if the players are not fit, the probability of losing the match is what? What is it going to be? 0.45. How did you get it? It is 1 minus 0.55. This one. So this is going to give us 0.45, not winning the match. Okay. So here the question is looking for, when you are able to draw the tree diagram nicely, you get mark for that. Then based on fitness alone, calculate the probability that Fana Soccer team will win the next match. We are talking about winning the next match. So here the players may be fit and they may win. So it is 0.7 and 0, n means times 0.85. So what we want is what? Win. So let me bring the tree diagram here to use it to explain. Okay, so here for them to win, the player may be fit and win, or fit and win, or the player may not be fit and win. The player may not be fit and still win, which is this one. All in probability is what? Plus. So the player may be fit, which is 0.7, and win, which is 0.85, or all means plus. The player may not be fit, which is this one, and still win, which is this one, 0.45. And if you multiply this and this, you get this one, plus this and this, you get this one, which will give us 0.76. Okay, and 0.76 is what? 76%. Okay, now this is going to be your classwork. So your classwork is this one. You pause the video, you copy it nicely, then you do it. Okay, I wish you all the best. Bye. Keep on studying.